Chapter 3. We're understanding the Zen of Python, introducing object-oriented programming, discovering why indentations are important, and using Python modules. So this will be a lot of fun. Python elements and syntax. We're getting started here. Many programming languages focus on things that the computer does and how it does them, rather than the way humans think and work. This one simple fact makes most programming languages difficult for most people to learn. Python, however, is based on the philosophy that a programming language should be geared more towards how humans think, work, and communicate than what happens inside of a computer. The Zen of Python is a perfect example of that human orientation, so we'll start the chapter with that topic. The Zen of Python is shown in Figure 3.1, and it's a list of the guiding principles for the design of Python. The principles are hidden in the Easter egg, which is something in a programming language that's not easy to find, and it's an inside joke. But to get the Easter egg, go to the terminal, type in Python, type import this, and you'll get a list of these aphorisms. Let's read them. The Zen of Python by Tim Peters. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. Although practicality beats purity, errors should never pass silently, unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. That's a good piece of advice regardless. There should be one, and preferably only one, obvious way to do it. And although that way may not be obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one great honking idea. Let's do more of those. So this is the Zen of Python. The Zen of Python is sometimes referred to as PEP20, where PEP is an acronym for Python Enhancement Protocols. The 20 perhaps refers to the 20 Zen of Python principles, only 19 of which have been written down. We all get to wonder about or make up our own final principle. Many other PEPs exist, and you can find them all on the python.org website. The one you'll likely hear about the most is PEP8, which is the style guide for Python code. The guiding principle for PEP8 is readability counts, that is, readable by humans. Admittedly, when you're first learning Python code, most other code will look like gibberish scribbled down by aliens, and you may not have any idea what it means or does. But as you gain experience with the language, the style consistency will become more apparent. You'll find it easier and easier to read and understand other people's code, which is an excellent way to learn coding yourself. We'll fill you in on Python coding throughout the book. Trying to read about it before working on it is surely to bore you to tears. So for now, anytime you hear mention of PEP or PEP8, remember it's a reference to Python coding style guidelines from the Python website. And anytime you can search for PEP8. PEP8 is also referred to as PyCode style, especially in VS Code. This PEP8 business can be a double-edged sword for new learners. On one hand, you don't want to learn a bunch of bad habits, only to discover that you have to unlearn them. On the other hand, the strict habits or demands of PEP8 can frustrate you. So we'll follow PEP8 as we go along, and you can configure Pylint if you want to help you out with the PEP8 stuff. I recommend that we don't do that. All right, introducing OOP. That's right, not OPP, other people's property, but OOP, Object-Oriented Programming. OOP, you know me. At the risk of getting too technical or computer science-y, we should mention that there are different approaches to designing languages. Perhaps the most successful and widely used model is OOP, or Object-Oriented Programming, which is a design philosophy that tries to mimic the real world in a sense that it consists of objects with properties as well as methods, which are actions that those objects perform. So objects have properties like color or size, and then they have methods like push or pull. Take a car, for example. Any one car is an object. Pay attention to this really carefully. Any one car is an object. I'm not learning Python, I'm teaching Python. Not all cars are exactly the same. Different cars have different properties, such as make, model, year, color, and size. Again, pay really close attention. A car is an object, but not all cars are the same. Different cars have different properties. Make, model, year, color, size, and they're different from one another. And yet, they all serve the basic same purpose, to get us from point A to point B. All cars have certain methods, things that they do that are in common. You can drive them, steer them, speed them up, slow them, control the temperature, and more controls in the car that you can manipulate with your hands. Okay, what does that have to do with this? Well, an object is an object-oriented programming language isn't a physical thing. So an object in our programming language isn't a thing like a card, but it exists inside of our computer. It's a software creation. In Python, you can have a class. This is very important, which is you can think of as an object creator, such as a car factory, that can produce many different kinds of objects, like cars, for varying purposes. A sporty car, an off-road car, a sedan. All these objects can be manipulated through the controls that they have in common, much as all cars are manipulated by controls such as the steering wheel, brakes, accelerator, and gear shift. Python is very much an object-oriented language. The core language consists of controls in the form of words that allow you to control all kinds of objects. Again, objects. In your own and other people's programs. However, you need to learn the core language first, so when you're ready to start using other people's objects, you know how to do so. Similarly, after you know how to drive one car, you pretty much know how to drive them all. You don't have to worry about renting a car only to discover the accelerator is on the roof, or the steering wheel is on the floor, or you have voice commands rather than a brake to slow it down. The basic of driving applies to all cars. So we'll learn more about object-oriented programming at some point. Discovering why indentations count, big time. In terms of the basic style of writing code, the one feature that really makes Python different from other languages is that indentations, rather than parentheses, curly braces, and so forth, are used to indicate blocks, or chunks of code. We don't assume that you're familiar with other languages, so don't worry if that statement means nothing to you. But if you're familiar with JavaScript, you know that you have to do quite a bit of wrangling with parentheses to control what's in the code. For example, here's some JavaScript code. You see all these parentheses and braces, right? So many parentheses, braces, and semicolons. The code is a mess and not fun to read. We can make reading it a little bit easier by breaking it up into multiple lines and indenting some of these lines. Doing that is not required in JavaScript. Now you can see that the code is a lot more readable, right? In JavaScript, the parentheses and curly braces are required because they identify where the code begins and ends. The indentations are optional. They're up to you for readability. The rules are the opposite in Python because it doesn't have curly braces or any special characters that mark the beginning or end of code. The indentations themselves mark those. So these indentations, they're not optional. They're required, and they have a huge effect on how the code runs. So when you read the code as a human, not as a computer, it's easy to see what's going on, and you're not distracted by a bunch of quotation marks and all those other things. So here's the same code written in Python. It's only a couple of lines, and it's a lot easier to read. You may have noticed that the top of the Python code starts with import. Lines that start with import are common in Python, and you'll see why in the next section. So it says import random up there. Using Python modules. One of the secrets to Python's success is that it is comprised of a simple, clean core language. That's the part you need to learn first. In addition to the core language, there are many modules that you can grab for free and access from your own code. Those modules are also written in the core language, but you don't even need to see that or know that because you can access the power of the modules from the core language. Most modules are from a specific or for some specific applications such as science or AI or working with dates or time or whatever. The beauty of using modules is that other people spend a lot of time creating, writing, and fine-tuning the modules so that you don't have to. You simply import the module into your own Python file and use the module's capabilities as instructed in the module's documentations. For example, we had that magic 8-ball program that started with the code import random. Interesting, right? Import random. The core Python language has nothing built into it to generate a random number. We could figure out how to make a random number generator, but we don't need to because somebody else did, and they made the code freely available. So if we start with import random, it tells the program that you want to use the capabilities of the random number generator module to generate a random number. Then later in the program, you can do that with answer equals random.randint18. This is a line of code. Hundreds of free modules for Pythons are available. You just need to know which ones to import in your program. You may be wondering where to find all these modules. Well, they're all over the place online, but you'll probably never need to find and download them because you already have most of the modules, the widely used modules in the world. They're all in Anaconda. So if we open up Anaconda, click Environments, look at all these modules. They're all installed already. One of the nice things about Anaconda is that to get the latest version of these modules, you don't have to do any weird pip commands. Instead, just click the arrow or version number of the module you want to download and click apply. So I can click here, I think, and click apply. And this sort of like upgrades it to the latest version. Pretty cool. Anaconda does all the dirty work. All right, so for the syntax for importing modules, you must import a module before you can use it. So you do import module name, and then there's this optional as alias. Code written in a generic format like that, with some parts in italic, some in square brackets, is sometimes called a syntax chart because it's not showing you literally what to type. It's showing you the format or syntax of the code. Here's how information is presented in a syntax chart. The code is case sensitive, meaning you must type import and as using all lowercase letters as shown. Anything in italics is a placeholder for the information that you should supply in your own code. For example, you would replace the module name with the name of the module you want to import, but this is the code you have to type exactly. It's in monospace without italics. Anything in square brackets is optional. So this is optional. And you never type the square brackets. You can type the import line at any place you type Python code. At the command prompt, in a Py file, in a Jupyter notebook. In a .py file, always put import statements first so their capabilities are available to the rest of the code. Using an alias with modules. You just saw that the import's command syntax, you can assign an alias or nickname to any module you import just by following the module name with a space, the word as, and a name of your choosing. Most people choose a short name that's easy to type and remember, so they don't have to remember the long name every time they want to access the module's capabilities. For example, instead of typing import random, you could type import random as rnd, which is a shorter nickname. Then you don't have to use the full name random. You could type rnd.randint18. Using an alternative name doesn't seem like a big deal, but some modules are pretty lengthy, and you want to refer to modules in many places in your code. So now we're going to get our hands dirty with real Python code here in the next chapter. This is chapter 4, opening the Python file, using comments, understanding data types, doing work with Python operators, creating variables, understanding syntax, and organizing code. So this is really the first real chapter. So building your first Python application. So you want to build an app in Python. Whether you want to code a website, analyze data, or create a script to automate something, this chapter gives you the basics you need to get started in your journey. Most people using programming languages like Python to create app programs or application programs, which are often referred to as applications, apps, or programs. To create apps, you need to know how to write code inside the code editor. You also need to start learning the language, which is Python. Like any language, you need to understand the individual words so you can start building sentences and finally blocks of code that will enable your app to work. First, we walk through creating an app file in which you'll create your code. Then you'll learn data types, operators, and variables, which are the words of the Python language, and then Python syntax. Along the way, you'll save your app, catch mistakes with linting, comment your code so that you and others can understand how you built it and why. Are you ready? All right, so we're using VS Code. We got our hello.py file. Why don't we use that? There it is. Hello.py. You see that? Let's start with a comment. A programmer's comment, or used as usually called a comment for short, is a text in the program that does nothing. Which brings up the question, if it does nothing or doesn't do anything, why type it in? As a beginner, you can use comments in your code as notes to yourself, so you know what the code is doing. This can help a lot when you're first learning. However, comments aren't just for beginners. When working in teams, professionals use comments to explain to team members what their code is doing. Developers will also put comments in their own code as notes to themselves, so that if they review the code in the future, they can refer to it in their own notes for reminders as to what they did. Because comment isn't code, right? Your wording can be whatever you want, but you have to start with the pound sign or triple quotations. So I use pound for most of my comments in Python. This is a comment in Python. You can also do triple quotes. Hold on. So you can see it'll turn green if that's the right way to do it. So triple, I guess, double quotations like that, and then inside. No, this doesn't seem to be turning green. That's why I only use the hashtag. Well, it says, although we won't use multiple line comments yet, be aware you can type longer comments by enclosing them in triple quotation marks. These larger comments are called doc strings and often appear at the top of a Python definition, which are apps building blocks that you'll learn later on. It isn't necessary to do one yet, but here's an example of a multi-line comment. Yeah, it doesn't have to turn green, I figured that. It'd be nice if it did. At the beginning and end of the comment, you can use 3 single quotations rather than double quotations if you prefer. Comments are usually colored differently. Doc strings are colored brown. Okay, well, that's helpful. You can put an unlimited number of comments in your code. If you're waiting for something to happen, don't. When you're working in an editor like this, the code doesn't do anything until you run it. And right now, all we have is a comment. So even if we did run this code, nothing would happen because comments are for human readers, not for computers. All right, let's start with the absolute basics. So right now, we're starting programming. So if you haven't listened to anything at all, you're pretty much okay because all this setting up stuff and tooling stuff is important, but this is the really important part. This is actual programming. Understanding Python data types. Ooh, really exciting. You deal with written information all the time and probably don't think about the differences between numbers and text. Numbers are amounts, just 10 or 123.45. Text consists of letters and words. For computers, the big difference is that they can do arithmetic, like add, subtract, multiply, or divide with numbers, but not with letters or words. For example, everyone knows that 1 plus 1 is 2. The same doesn't apply to letters or words. The expression a plus a doesn't necessarily equal b or aa or anything else, because unlike numbers, letters and words aren't quantities. You can buy 12 apples at a store because 12 is a quantity, a number. You can't buy a snorkel apples because a snorkel is a thing. It's not a quantity, a number, or a scalar value. I wish I could buy snorkel apples. I would buy those right away. Numbers. Numbers in Python must start with a number digit, 0 to 9, a dot or period, which is a decimal point, or a hyphen, which is used as a negative sign for negative numbers. A number can contain only 1 decimal point, obviously. It should not contain any letters, spaces, dollar signs, or anything else that isn't part of a normal number. Python has the following rules on table 4.1, which shows good and bad Python numbers. Okay, 1, that's a good number. That's a whole number. It's an integer. 1.1, that's good too. That's a number with a decimal point. 1234566.89 or 1234567.89. This is a larger number with a decimal point, and again, no commas, really important. No commas allowed. -2, this is a negative number indicated by the hyphen that starts the number. 0.99, this is a number, it starts with a decimal point, and it's less than 1. Okay, here's some bad examples. $199, that won't work. That's not a number in Python. You can't have the dollar sign. 12,345.67, that's also bad. You can't do that. You can't have any commas. We're reading from Python All-in-One for Dummies by John Shkreli and Alan Simpson. Okay, here's another number. 11013232. This is bad. It contains a space. No space is allowed. This one looks like a social security number, like 91740-3384. You can't have that. You can't have a hyphen. Here's the social security number. You can't have 2 hyphens. Here's 123 Oak Tree Lane. You can't have any spaces or letters or words. Here's a phone number. You can't have that either with parentheses and hyphens. And here's an IP address, 127.0.0.1. You can't do that either. No decimal places are allowed. No multiple decimal places. Only 1 decimal point is allowed. If you're worried about the number rules that won't let you work with dollar amounts or zip codes, stop worrying. You can store that kind of information. You'll see that in a minute. But the numbers have to match these 4 or 5 good first examples. 1, 1.1, 1, 2, 3, 4, 5, 6.89, -2, 0.99. If you're looking at the code for more advanced scientific or mathematical applications, you'll sometimes see the E or J. And Python does support a few different types of numbers that we didn't cover yet. So integers are any whole number, positive or negative. No limit to its size. That's really interesting. There are limits in other computer programming languages. Numbers such as 0, -1, or all these 9s are all perfectly valid integers. From your perspective, an integer is just any valid number without a decimal point. That makes sense? Floats. A floating point number, which is often called a float, is any number that contains a decimal point. There's no size limit, so 1.1 or -1.1 or 12345.7890123455 are all valid floats. But if you're working with very large scientific numbers, you can put an E in the number to indicate a power of 10. For example, 234E1000 is a valid number, and it's treated as a float even though there's no decimal point. If you're familiar with scientific notation, you know that 234E3 is 234,000. The E3 is just 3 zeros. If you're not familiar with scientific notation, don't worry about it. Complex numbers. So if you know much about complex numbers, these bizarre little charmers always end with the letter J, which is the imaginary part of the number. If you have no idea what we're talking about, you're normal. Only people deep in math land can care about complex numbers. All right, words. So now we're getting to the second data type. So we talked about the first data type, which is numbers. Now let's talk about words, which are strings. Strings are the opposite of numbers in a way. With numbers, you can add, subtract, multiply, and divide because numbers represent quantities. But strings are for everything else. Names, addresses, all kinds of text you see every day would be a string in Python and in computers in general. It's called a string because it's a string of characters, like letters, spaces, punctuation marks, and maybe some numbers sometimes. To us, a string usually has some meaning to humans, like a person's name or address. But computers don't have eyes to see or brains to think or any awareness that humans even exist. So to a computer, it's just a piece of information that you can't do arithmetic with. It's a string of characters. Unlike numbers, a string must always be enclosed with quotation marks. So if you don't enclose them with quotation marks, it often will result in an error or something like that. And a number, if you want to multiply and add with it or do any other operation with it, you can't enclose it in quotation marks. So you just got to remember this. So here are a bunch of valid strings. And you can use double quotations or single quotations, but you just have to keep them consistent within the same string. It's fine to use numeric characters, hyphens, dots, and periods in strings. They're all still strings as long as they're inside the quotation marks. Just be careful if you need a quotation mark in your string. So sometimes like here, if you have Mary's dog said woof, well, you have a single quotation for Mary's, but I would put that string in a double quotation. But let's say you have the other way around. If you did it like this with all single quotes, your computer will mess it up and think that you terminated the string after these two. So it would see the first quote sign, and then after the next one, it wouldn't know what to do with the rest of the stuff, and you'd get an error. So here is the same way. If the dog of Mary said woof, and you would put the double quotations around woof. So it's a little tricky sometimes when you have to work with these quotations. If you have like a situation where you can't even fix that, you can do something called an escape character, and this is important to learn. Escape characters basically let you escape out of the situation. So if you press backslash, that's usually the sign for an escape character. So you can do everything normally if you press backslash. So here, you don't want this quotation. Let's zoom in a little bit because this is so important. You don't want this quotation to end the string, right? You want the string to end here where it's supposed to. But the computer doesn't know that this quotation is a special quotation. So how do you make it a special quotation? You put this backslash. And you're going to see that quite a lot. We'll get to lists and tuples in a second. All right, so \n is the new line. So that's another sort of important escape character. So sometimes you want to have like an enter, right? A new line. So just \n is a good way to do that. So when you display the old pawn \n, a frog jumped in \n kerplunk, it will look like this, which is a lot better. So each \n was converted to a line break.